Well, what does radiation do to living organisms? What's called acute radiation is what happens when you have a large exposure in a short period of time. Big exposure to radiation. This sort of thing would happen with some sort of a nuclear accident, perhaps, nuclear bomb. When this happens, a large number of cells die, especially those in your immune system and in your intestinal lining. So then your immune system's weakened, making you susceptible to any virus or bacteria that comes along, and you're not able to absorb nutrients from your food, so you're going to become malnourished. If you have a mild case, it is possible to recover from acute radiation exposure, but death due to infection usually happens from higher exposures. Low doses of radiation over long periods are also harmful, and the main harm here is that it increases your risk of cancer. Radiation can damage your DNA, and when damaged DNA reproduces, it causes problems. It causes cells that can grow out of control. So the more radiation you're exposed to, the more increase in cancer risk you have. You can't really say, well, at this level you're okay, and above this you're not okay, because it's not ethical to do experiments on people, right? Okay, who wants to volunteer to be exposed to radiation and see if you develop cancer in 10 years, right? Nobody's going to sign up for that. So they're very limited in the sorts of information they can get. So when an exposure does happen, they're going to collect all the information that they can. But our knowledge of this is a bit sketchy. Radiation exposure, besides causing cancer, can cause genetic defects. And those genetic defects can be passed on. You may see the effect in the person's children, or it could be passed on and show up later. So if the DNA in the eggs or sperm are damaged, you can have abnormalities. Those genetic defects have been observed in laboratory animals. They've not been verified in humans. Even after studying survivors of Hiroshima, they've not verified that that actually happens. Radiation exposure is measured for people working with radiation, and so you need units. I just want you to know about the units. We're not going to do conversions or anything with these. There's different ways of measuring radiation. It's not as simple as measuring a length or a mass or something. So we can measure it as number of decay events to which you've been exposed. So the Curie is one unit for that. It's 3.7 times 10 to the decay events per second. A Röntgen is a similar unit, but this is 2.58 times 10 to the minus fourth coulombs of charge per kilogram of air. Kind of a weird unit. When we're looking at human radiation exposure, it's often expressed in REM, R-E-M, which stands for Röntgen Equivalent Man. That's a weighted measure of radiation exposure that accounts for the ionizing power of different types of radiation. So the decay event is one thing, but what kind of decay that is has an effect on how much damage does that do, how serious is it. How are we, as just regular people, being exposed to radiation? On average, each of us is exposed to approximately 1/3 of a REM of radiation per year. That's Röntgen Equivalent Man exposure of radiation. Where does that come from? Over half of that is from naturally occurring radon. I grew up in Minnesota and Iowa, and in Iowa, there's a fair amount of radon naturally present in the soil. And so it's important to check the air in your basement because radon is a gas, and so you're going to breathe it in, and then you've got it inside of you, and so that can cause a lot of damage. So you want to check for radon in the basement. It's produced by uranium decay, so it's just continually being replenished. Cosmic, terrestrial, internal exposures. Consumer products, small part. Medical exposures, fairly significant part. You get dental x-rays, you break your leg, you get an x-ray, you get an MRI or various things, that's exposing you to radiation as well. They measure that very carefully and always consider the cost benefit, right? Is this beneficial to do this or not? And does the benefit outweigh the risk? So you try to minimize that. To have a measurable health effect in a human being takes more than just natural exposure. If you're just, going around, even if you're digging in the dirt and stuff like that, you're not going to get enough exposure to cause health problems. The first measurable effects, which would be something like decreased white blood cell count, are going to occur if you had an instantaneous exposure of approximately 20 rem. So natural plus environment, like medical exposure, gives us a third of a rem in a year. So to have an effect, 20 rem all at once, at one time. Decreased white blood cell count, possible increase in cancer risk. Higher, you're going to get the radiation sickness, skin lesions, also increase in cancer risk. 500, you're dead.